Hey guys, welcome back to another episode of Simuleos. Let me go ahead and very quickly change the camera angle, make sure everything's set, and we should be good to go. So, what are we doing today? Well, today, unfortunately, here's the thing guys, I was intending to have today be totally about genetic algorithms, all that kind of nonsense, right? But, basically I didn't have time to study up the genetic algorithm stuff. There's a number of reasons for this. Yesterday I spent basically the entire day. In the morning I spent the time all doing the video editing for the four-dimensional stuff. Let's see, Sunday, for some reason, the entire day was just completely covered with one thing or another, so I just ran out of time, guys. There's a problem being that I have a real life too, and I need to actually use, I don't know, I guess I need to do things in real life, which makes it so it's hard to do everything on stream. Now, that said, I have been looking up genetic algorithms. I have an idea of what I want to try, but I don't know if it's going to work or not, so we'll see how far we get there. Outside of that, I guess we'll just go ahead and get started with today. It's going to be a bit of a short day. In fact, a lot of a short day. Basically, I just had a few more visualizations I needed to finish. I'm hoping to finish the stream maybe around 6-ish, so just a very quick stream today. And then I'm going to finish up editing my video, which should be out, I'm hoping, by either the end of today, my time, or early tomorrow. The thing is, I've been trying really hard to get videos out more frequently, but it is a pain. I can't do it. No matter what I do, I just cannot seem to get videos out every 2 weeks. That was my goal, get videos out every 2 weeks, and it seems like every 3 to 4 weeks is the natural cadence of this channel. And though that is okay, obviously the faster you can get videos out, the better. So this is something that I was trying to fix. Anyway, let's go ahead and get started with today's episode. So we're going to CD into projects, Simuleos, visualization, and of course fourth dimension. And there's one thing that I did last time, or yesterday, that I did not show you guys. So let me go ahead and CD over here too. There we go. And let me just do a quick LS. Okay, so it looks like I don't have them here. So let me instead do an LS of storage, videos, and let me see, what do we have here? Videos, and there was one more thing. It should be 40, I think. Okay, so here we have a whole bunch of rotations here. And what I want to do is I want to show you guys one video. So let's do MPV. Where are we here? Storage, videos, 40, and double rotation, projection, 1 second, range, yes, something like this. Hey, gust run. Okay, and I'm going to do loop 0, and I'm going to increase the speed, which you'll see why in a second. That was seep. I want to spell speed. Okay, so here we have the rotation that we're used to looking at, except in this case I am changing the projection of this guy. So I'm changing you know how we have that L minus W term that we have in our projection matrix? Basically I'm changing that projection, and we can see that the rotation looks dramatically different. Here's what the rotation is supposed to look like without that change in the projection. So if we go here and we run, I think it's double rotation, I think that's it. 1 second, let me see. Double rotation here. Yes, okay, so this is what it would naturally look like otherwise. So we have obviously a rotation like so. However, when we change the projection matrix, we see that the matrix changes dramatically, and that's pretty cool. Or the transformation changes dramatically, which is pretty cool. Now, there's a few more things I need to do here, guys. And these things are not really four-dimensional visualizations, but three-dimensional visualizations, which are quite important. So let me go ahead and run what we need. So first of all, I need an image of a cube. Then I need an image of a cube being sliced with that blue sheet that we made last time along Z, Y, and X. And then I need, let's see, an image of 2 sheets that are connected with rods. And then finally I need an image of a light being shined down on the object and kind of showing that as the light goes in and out, the shadow grows and shrinks in size. So let's go ahead and get started. VI. 1 second. What do I want here? I guess I want VI fourth dimension.py. And guys, as I mentioned just a second ago, I just was not able to look up the genetic algorithm stuff, and I've been running out of time left and right, so I need something to kind of, I just need something to allow me to more easily, I guess, I need one more day, basically is what I'm saying. At least one more day. I might need 2 more days. I apologize for that one, guys. Part of the problem with learning on the fly like this is that at some point, you don't run out of things to learn, but you run out of time to do the learning, and this has been my problem lately. So let me go ahead and run another ls of the directory that we just at, storage, videos, 4Dimension. And let's see, what do we have here? We have grow, we have out. Let me see, what do I want? None of these guys, it looks like. So let me go ahead and change the number here to 100. Start with the on, guys. And let's do cube slice of 100. 1 second. Go down here. Oh, I don't know what that did. Nope. I don't know what I'm doing. Here we are there. Okay, so let's run this. So we're going to run blender -b-p 4th dimension.py and give this guy just a second to render all the frames. It shouldn't take too long. By the way, guys, I've noticed that as Blender is rendering all the frames, it takes so much processing power, which I suppose I remembered last time, but I totally forgot in the last time, since it's been the last time I used Blender. So, why is it going? Oh, it's going 100 frames. Good. I found out that LuaKit, that browser that I told you about, is much, much faster than Chrome, and Chrome slows down a lot when Blender is doing its, massive simulations, but LuaKit doesn't. So that's quite nice if you're interested. So let me run the last MPV. So I think it's gonna be MPV out. 1 second. Out.mp4. Okay, so there's a slice along the z-axis. Looks pretty good to me. So then what I want to do is do one along the x and y axes. So let's go ahead and do that one. So what am I going to do? I'm going to go ahead and CP this over to where we need to go. So I'm going to basically create a second terminal here. The problem is, guys, when I usually do my development, I have like 5 terminals up at once, and like I have a whole bunch of room. But here, because I have one terminal dedicated to chat and another terminal dedicated to, actually running the code, which I always do, I just don't have enough space. Hey, Kark, thanks for coming in. I realize you are probably, you're probably heading out. So have a good day. Good luck with everything. See you around, man. It's going to be a bit of a short stream anyway. So let's go ahead and CD into storage. Then I want to go into videos and 4D. Okay, now we're going to move. Let's see, what do I want here? I think I want projects. There we go. Simuleos. Visualization, 4th dimension. And then I want out.mp4. And I'm going to put it here, and I'm going to change the name to zslice. Zslice. 1 second. zslice. Oh. Yeah, that's fair enough. Kark, you said you were leaving, so don't give me that. MP4. Okay. Should be okay. Oh, that was a comma. Change this to a period. Okay. Let me do an ls real quick. zslice, comma mp4. I guess maybe I need to do. Oh, I see. To zslice dot mp4. Okay, there we go. The main one being sandboxing, but also has pretty aggressive caching. Okay, so let's go over here, and now let's do the other 2 dimensions. See ya, Kark. Thanks for coming in. Yeah, I guess I just don't know very much about internet browsers. I guess in some sense maybe I should, but I don't. So let's change this. Let's see what happens if we do rotation. Equals, actually, I don't know how rotation works. So let's go down here, and let's not render the movie. And let's go over here, and let's run blender-p 4th dimension.py to open it up. And now let's see what we have here. So if we go down to the plane, should be around here somewhere, plane. Let's go here to the location, rotation. It looks like if we rotate this to 90, yeah, that's what we want. So we want that to be 90, and then the other one we want this to be 90. Or not. 0. Oh yes, so we did want that one to be 90. Okay, so one is going to be along X, and the other is going to be along Y. So let's see what happens if we go ahead and initialize it with a particular rotation. Rotation Euler. Rotation Euler. So I think we would do rotation Euler equals the following. So let's see what happens. Let's go. So where are we here? We are going to say, where are we? Project cube. I want to go up to slice cube. Cube slice, that's fine. And where are we? We're here. So we go ahead and add in an additional line down here. And let's do rotation Euler equals 1 second. Equals, and then I want to do 90, 0, 0. And let's see if that does it. Blender-P. This one's broken. Good, okay, so what do we have here? Cube Slice, Rotation Euler, unrecognized. Let's try just rotation. Blender. Let me see. Okay, that wasn't what I meant to do. Okay, let's try this again. Okay, so this is almost what I want. Let's see, what's the rotation over here? For some reason, rotation is 5156 degrees. Not exactly sure why. I thought I gave it 90, but for some reason it says 5156. Why would that be the case? 90. Wait, what? Where is that number coming from? Is it flipping? Nope. Let me see. Length of connectivity is 12. Alright. It's just going upwards. Where is this value coming from? Let's go ahead and highlight the plane. Go over here. Yeah, 5156.62. Okay, let's try the initialization of, what do we have here? It's primitive plane add. So let's go over here. Primitive plane add. And let's see, what do we have? Primitive cube add. Okay, this is fine. Enter mode, relocation, rotation. Yeah, dang, the rotation is totally... Okay, let me see. Rotation is totally 0, 0, 0. 1 second. Is this maybe in... Let's try numpy.py times 0.5. Let's try this one. Okay, there we go. That one did it. Good, good. So now that that's set, we just move it along X, and we should be set. Yep, that's exactly what we need to do. So let's go down here, and let's see. We have 0, 0, and then we have this guy here. So all I want to do is, because this is X, Y, and Z, let's go ahead and do Y first, because this will be easier to do. So let's do 0 here, and let's add in a 0 here. And remove a 0 from back here. Now we're going to do Blender-P, and I want to do -B-P because I'm pretty certain this is going to work. Okay. Oh, yes, this is because I need to go down here and render the movie. Blender. Okay, give it just a second, 100 frames, and we'll check out the video. Check out the video. Okay. Now let me think. What is something else that we can do here? There's a line that I say in the video where I say that if we have two planes, one at z equals -0.5 and another at z equals +0.5, and we connect these two planes with lines, we basically generate the another cube in a way, where if the lines represent all of the different possible... Okay, so I know what I need to do here. So let's see, Blender-P, let's run the last MPV. Oh, well that didn't do exactly what I wanted, did it? Let me go up here and let's see what we got. Let's see, rotation should be along Y. What? Rotation is along Y. The movement is along Y. 1 second, let me just go ahead and check this. Let's go down here to the bottom. Not render the movie. That was my bad for being a little bit too believing in my programming abilities. For newcomers, never believe that you know what you're doing. This is always a bad thing. Let's see, that's along Y there. Okay, so what we need to do then is move this one along X. So let's go ahead and change... Yeah, so let's go ahead and change the rotation. Where are we here? Rotation up here. Project cube. Okay, it's up here real quick. Let's change the rotation so it's along X again. And then let's add a 0 along here. Okay, that was me failing miserably. Thanks for watching. Okay, now we're going to go over here. We're going to run Blender-B-P. But first, I want to go over here, pop down to the bottom, and now we'll render that movie. So let's run Blender-B-P. Enter. Give it a second to do its thing, and then we should be good to go. And that'll be the second visualization we need to do. We need to do the same thing for Y. And that'll be 3 out of 5 visualizations we need. So after this, we need to do one more visualization with the planes, and then we have a final visualization to do projecting the plane onto a sheet, and then we're good to go from there. And after that, we have all the videos ready for my YouTube video. I apologize, guys, for doing a stream kind of like this. It's just I've been running out of time. I have so little time nowadays. And it's just because it's the month of November. Any other month, I'd have more time, but somehow a lot of stuff happened just this month. So let's do MPV. Okay, that is a slice along X. So let's see, we went up. We went this way. Just when I thought Twitch finally managed to get its stuff together, the stream starts buffering. Oh, 1 second, let me check online. So let's go here. Do you have quality options today? No, you do not. So there isn't very much I can do. Yeah, there isn't very much I can do about that one. I'm running with a bitrate of 2000, so it should be reasonable. So let's go up here and let's go ahead and change this. Let's do X and let's do Y. Let's see. So if we change this to a 0 here, and then we remove the 0 here, we go down here, we remove a 0 from here, and add 1 to the end. This should be everything we need for that last visualization. So let's go over here, 0 there, add in an extra space, and remove a space there. And now let's do blender-b-p. Let's see what happens. Give it some time, and oh, dag-nabbit. I forgot to do something. I totally forgot to do something. So we're going to have to redo the very last visualization we did after this one's done, because I'm re-outputting out.mp4. Oh well. So let's give this guy a second to render, watch how it fails, and then we're going to go back and render the last video, which I failed to do, and then we should be good to go from there. Okay, 1 second. Give it a second. Now let's run the last MP4. I'm sorry, MPV. Okay, this one actually looks okay. Yeah, that one looks okay. So now let's go ahead and copy this over to where it's supposed to go, which is going to be there. And let's move 1 second. I think it's going to be up here. And we want to do Y slice, or X slice, I guess. .mp4. Yep. Okay, so now let's go over here. And let's now do the last slice, which is the slice we just did, but I accidentally erased it. So let's do this. Over here. Add in a 0. Go down here, add a 0 up here. Remove a 0 down there. 1 second. 0 here. And now we're going to run blender-p, fourth dimension up high. And this should be along the other dimension. And then we should be good to go. 1 second. It's going to take a little bit of time. Sorry about that. Give it just a little bit of time. And then we're good to go from there. So that's that visualization there. Now, the last visualization we need to do, let me think, is going to be a little bit trickier, but it's not going to be so bad. Let me think. I guess what we need... Yeah, okay, I think I know what we need. We need... Yeah, okay, I know what we need then. Let me go ahead and run MPV. Yep, so that is the last dimension. Looks good to me. So now we're going to CD over here. And we're going to run Y slice. Okay, so now we have all the slices set. What do we have to do next? Next, we have to do a little bit of a more complicated visualization. So let's go over here and let's do it. Oh, we're already in cube slice. My bad. Okay, so in the end, we're going to want to, basically I want to show that we have 2 slices along the, yeah, okay, I know what I need to do. Yesterday I re-downloaded TIS 100. Man, I forgot how much fun that game is. Yeah, so it's one of those games that I think, I don't know, I've seen a lot of people play it. I've been thinking about playing the game on stream actually, but I've decided against it after a lot of discussion in my head. So let's go here and let's see, what do we have here? So we have bpy data objects original hide render true. Okay, so I know what I want to do then. For I in range, what I'm going to do is I'm going to add 5 here. Plus 5. And we're going to go down here. Yeah, that should be okay. So I'm going to add 5 there. Because I only need a few images beforehand. And now I want to create a couple planes. But what I think I'm going to do is I'm actually going to create these planes in... Yeah, I know what I'm going to do. Okay, I might just use Blender for these guys. So let's go ahead and run this real quick. Back to what it was before. Resolution here. And let's go over here and let's change it so there is no rotation anymore. Now let's go here. Let's run Blender-P. 1 second. Fourth dimension.py. Pop down here. Not render movie. Okay. So we're going to do Blender-P fourth dimension.py. Okay. So let's go ahead and run that. We should have... yes, except the location seems funny, and this is because I started at the incorrect location. So let me go up here to slice plane. Where are we? Final cube. 1 second. Wait, where is it? Slice. Here we are, cube slice. And let's change the location so it is X, Y, and Z. That seems right to me. Primitive location. Wait, what? This should be okay. Blender-P. X, Y, and Z. The location should be... Totally... Oh, I see the problem. Yep. Totally see the problem. Let's go down here real quick. And let me change this so it's moving along Z instead of Y. So let's add a 0 here. Good. Okay, let's go over here. Blender-P. Now it should be... Yep, at the right spot. Okay, so we're going to start with the plane here. Then what I want to do is remove all the other objects. So let me just go ahead and take a couple snapshots here. Okay, so the first thing I want to do is take a snapshot when the plane is invisible. So let's go ahead and remove the plane. And now let's do a quick render. Okay, you really should have been gone from the... Shoot. So let me see. Let's go here. And let's see. Insert keyframes, unset... 1 second, I gotta think here. How do I... 1 second. There we go, let's try this one. There we go, okay, so it's hidden from the render. That's what I want, just a simple cube. So let's do file, wait, where did this guy go? Did it go to temp? Let me CD into temp. Let me do an LS here. We have... CD Blender. No, okay, so I don't know where that image just went. Let's see, so let me just go ahead and give it a location, and hopefully this will output it somewhere that I want. Let's go up to storage, videos, nope, that was lost and found, videos, 4 dimension, and let's accept that. And then we're going to say cube dot PNG. Okay, let's try rendering that one. Okay, so now I want to do a quick ls of storage. 1 second, storage, videos, 4 dimension. Let me see, what do we have here? We do not have it, I don't think. Cube. No, we don't have it. Okay. So now the question is, why don't we have it? And that's a pretty good question. Well, I'm off topic. I managed to finish all the 800 Japanese flashcards. Dude, fantastic. You're way ahead of me then. I really need to learn some Japanese, but I keep not learning Japanese. So let me go up here real quick. No? Oh, here's the presets. Let's change this to 100%. X, I don't know. There's something I'm missing here, guys. And I'm not sure what it is. How come? Placeholders. Post-it output. Yep, I just want a cube.png. Placeholders here. Oh, maybe. Let me see. Render here. Animation there. I can do an animation, I guess. Render layer here. But I just want to render a single image. But where did this image render to? 1 second. Shading performance. Overwrite. File extensions. Placeholders. Yeah, I just want a PNG. Where'd you go, man? Let's render this again. 40 cube.png. Yeah, that seems like it should have worked. Okay, so here's our render. And let's pop over here. Run a quick ls. Oh, let's CD into storage. Videos. 4 dimension. Let me do an ls here. I don't see it unless I'm missing it. So let me see. 40.blend1, 40.blend2. Nope, this isn't it. Let me do an ls in temp. Quit.blend? No, it's not there. So let me just Google this real quick. Yes, so... Yeah, I gotcha. Sorry about that. I had intended to do genetic algorithms today, but I just ran out of time. So let me do rendering a single image. Blender. Because for some reason I'm not able to do this. No file output after rendering. Good, this is probably the problem. And let's see, what do we have here? Save as image. Okay, this is fair enough. So we have the render, then we do image, and then let's do save all. Let's do image, save as image. And now we go up here real quick. Choose storage. Videos, 40. And then I want to do, one second, I gotta think here. This is gonna take some time for me to think. I want to do cube. One second, cube.png. Save as image. There we go, that's what I needed. So now after that, let's go over here. And let me do a quick ls. We should have a cube somewhere in here. Let's do Mirage cube.png. Okay, good, so we have our cube. So now we have the cube. What else do I want? I now want two different planes without the cube. So let's go ahead and go back to the 3D view. Where's the 3D view? Where are we? What am I doing with my life? Here it is. And then I want to go to 3D view. There we go. And I want to change this so the plane is now rendered. And I want to copy the plane. So how do I copy something? Let me see. Control C, Control V maybe? Yep, plane 0.01. That's good enough for me. So now we're going to change this guy's location to be at Z equals +1. There we go. And now we need one more copy of this guy, Control C, V. Good. Okay, so now we should see which... Oh. We have to remove some of these guys from keying set. So let's go here. And let's delete keyframes. Okay, one second. Clear keyframes. Yes, that's probably what I want. There we go. So we have one plane moving up. Next one down here. Let's see, where's this guy? And we want to remove, delete, replace, delete, single key, clear keyframes. Okay. Then we have these two guys. And let me zoom in real quick just to check what we're doing here. Okay, so now I have to change the locations of these two planes. This plane right here should be at location -1. And this plane right here should be at location 1. Okay, so now we have everything we want. It's a big data analysis in general helps in your life. I don't know what you mean, Spark. Sorry about that. I'm not quite following. So let's go here. Okay, so now what I want to do is I want to render just these planes, the two planes up top. Because I think, actually, let's do one plane, then the other plane, then, yeah, so one plane, then the other plane. And then after those planes, we then go from there. So let's go ahead and get rid of all of these guys here. Get rid of all of them. I don't know if there's a way to just do this easy in a more, simple fashion, but that's okay. Let's grab all of these guys, except for literally one plane. Almost there, guys. Okay, good. So we have plane 2. Although I think... Yes, this is a plane I don't want. I want this plane. Okay, so now let's go ahead and render this. So we're going to go over here. Render that. It should be literally one plane along the axis. Good. Looks good to me. And now we're going to save that image once it's done. Yeah, once it's done. Give it some time. Okay, that's one plane. And let's go and do image. Save as image. And we're going to do plane 1. Let's go over here. One plane. Plane 1. And let's save that image. Gonna bring this up and let's do Mirage plane 1.png. Good, single plane. Looks good to me. Okay, now we need a second plane, so let's go ahead and do that one. So we want plane 2. So we're gonna render this image. Should be two planes right on top of each other. Fantastic, exactly what we want to see. Then after that, we say if we connect these with lines, also pretty simple to do. So we will go ahead and connect them with the boxes again. So let's do that. And let me see. So we are going to now do save as image. One second. And I want to do... One second, I gotta think here. I just questioned about your information dose per day. If you're talking about like the number of papers I read, I do read a lot of papers. I'm not gonna lie. I read a lot of papers. Okay, so here we have that. Now, last thing I want to do is let me go up and let's give all these guys visualization again. So we want to visualize everything. And then we want to render it into a movie. And that should be the very last visualization we need of this cube. And then we have one last visualization we need to do, which I think turned out really cool, but you guys can debate me if you don't want. Original does not want to appear. So now what we need to do is render this into an animation, which could take some time now that I'm thinking about it. So let's just do it. Okay. So this is going to be 100 frames. So we'll just give it some time to let it do its thing. So here we have the two planes. This actually might take some time. And then we have to continually move the planes forward. So that's one. Okay, wait. It says it's almost done with, oh, is that the rendering of one image? Yeah, that is the rendering of one image. I think the XY resolution is quite large. I think we could have probably cut down on the XY resolution here. Let's go ahead and close this real quick. Cancel this one. Can I cancel it? Yep. And let's change the XY resolution back to 50. And now let's do rendering the animation. Because even though this is 50, it's still quite large, you know? Like, it's, it should be exactly the size we need, even at 50% of the resolution we want. And then after this, we have one last visualization to do, which I think you guys are going to like a good bit. It looks really cool. I did it after stream the other day. And let me see, what do we have here? So, and then after that, guys, we're going to be done for the day. I've got to finish making the video, so that will take a little bit of time on my end. And after that, we'll probably be done. So let me see, where is this even rendering to? Let me do a quick ls of temp. Are we going to temp? I don't actually know where we're rendering to. That could be a bit of a problem. Yeah, let me do ls storage. Videos 4D. Okay, that's where we're going. Shoot, let me go ahead and close this. Okay, that was my bad. So let's see, CD storage. 1 second. Oh, that wasn't where I wanted to go. Storage, videos, 4D. Let me do an ls here, and let's remove cube.png 0 star. Okay. Now let me do a quick mirage of cube.png. Okay, so we have the cube like we expected. That's fantastic. So what I want to do now is I want to render it into an MP4 file. So let's go here and let's render it into an MP4 file. So let's do MPEG. Or, 1 second. This one should work. Cube.mp4. Encoding. Let's see, what do we have here? We want to do MPEG4. Okay, so now when we render it, it should be, let's say, slicing, and let's do slice and dice .mp4. Sure, why not? That'll do. And now we'll render this into a movie. And let's see what happens if we render that animation. You don't seem to be doing anything. Width is not divisible by 2. Width is not divisible by 2. What do you mean? Oh, so maybe we should, which one of these is not divisible by 2? X and Y. That's going to split into 4. That's going to split into 1. Okay, so if we increase this by 2, then it'll be divisible by 2. 1 second. I feel like I'm doing something really incorrectly here. What's the resolution of all my other videos? Let me see, what do I do here? I guess to check that, let's go back over here. Let me do an ls and let's see, what do we have? We have all these videos, and I think cubeslice xslice.mp4. Let's go ahead and open up that one. So mpv xslice.mp4, one that we just made. Okay, so what's the resolution of this video? How do I get that? I guess we have cube.png, but that's not quite right. Plane out. Oh, I bet you. Hey, TS Joss. I bet you it's going to be in this script over here. So let me see. What do we have here? We have resolution. We have define scene. I bet you it's down there. Let's do define scene. Or maybe it's in the render something. It's somewhere. I know I have this written down. Okay, so what do we have here? We have resolution somewhere. Oh, that's add lines. Scenes. Okay, let me see. Render file path, image, that's fine. Bitrate, MPG, max bitrate, out.mp4. Oh, dagnabbit. Image settings. None of this is what I want. I wanted a resolution. Maybe this is up here in define scene. Maybe it is up here. Let's see, define resolution. And this is going to be of size 1366 times 3, 1024 times 3, resolution wise 768. Oh, okay, I see the problem. Let's just go ahead and, yeah, so let's go here. And let's just render this. Let's just do 100% and let's just do render animation. Yeah, okay, this will take some time, but that's okay. We'll just kind of let it run. And then it should run slice and dice.mp4, and that should be okay. Let me get a quick sip of water, and then we'll be good to go from here. Again, there's 100 frames that need to be generated, and we are on frame 2 right now. So while it's rendering, feel free to talk about whatever you want in chat, because we got plenty of time for the rendering to happen. So... And one thing I wanted to point out, as these renderings are happening, it's using like literally all my processing power. If I go here and I run top, 1 second. Yeah, so all of them are like at 100%. So if you see any video lag or anything like that, it's probably because I'm doing this render. And the render takes a lot of time. Now, that said, I'll be totally completely honest, this video is probably a lot larger than the other videos I made. And that's my bad. I don't remember what the resolution was for all the other videos, so it's probably taking a little bit longer than it should. But that's okay, I guess. We'll just see how it goes. So yeah, let's see. Oh, yesterday I taught a skill pill. I told you guys about the skill pills, right? So these skill pills are kind of like, okay, so here at OIST, it's a fantastic university. I really, really like it here at OIST, but there are a few drawbacks to being at OIST. One of those drawbacks is that you as a student basically have to learn everything on your own. Okay? Now, this is okay, but there has been an initiative as of lately to basically create little teaching environments. So places for students to teach and students to learn, basically. And these are called skill pills. And the idea is that we basically provide a small amount of information incredibly quickly. It's kind of like a YouTube video in a way of learning. So like we have one coming up on Fourier transforms. Last night we did one on Nuplot. We've done one on terminal stuff. We're doing one on C++. We did one on Python. We have a whole bunch of languages on things that, sure, you can't really learn in a weekend, but we try anyway. And that's kind of the idea. So I like these skill pills. I think they're quite cool because they basically allow us as students to teach things that we wouldn't be able to teach before. Real quickly, I'm going to ls here, double rotation cube, and what did I call it? I called it slice and dice mp4. So it does look like we're generating the appropriate file. We just have to let it finish. So we are about 15% of the way done. So I imagine we'll be done with this rendering at like, I don't know, 6 or something. I'm not sure. Sorry about that, guys. It's going to take a little bit of time. So what am I going to say from here? Okay, so we have these skill pills. We taught one on Nuplot yesterday, but unfortunately I had completely forgotten that I was teaching that session until like yesterday when I met the skill pill manager guy and he was like, oh gosh, you have a skill pill tomorrow. And I was like, oh crap, I have a skill pill tomorrow. And so I had to teach it and I completely forgot what I was supposed to teach. So I kind of had to learn it on the fly. That said, it turned out okay. Honestly, it was probably one of the more relaxed skill pill sessions I've taught, and that's okay. It's good to have relaxed sessions like that. I think we got all the information out, so that's all we needed. But it was good. It was good. stupidly illogical language. I wouldn't recommend learning it. I'm sorry, Gastorn. Man, I really need to learn Japanese. Gosh darn it. What would you guys do if I just spent a full day, like just every Saturday or something, just spending like 3 or 4 hours just learning Japanese on stream? Would anyone be okay with this? I also, the other day, I posted to, what was it? I posted to the R Physics group on Reddit about live streaming physics, and at first it didn't get any notice. Like no one mentioned it at all. It was completely pointless. But after that, it got quite a few views. I was quite happy with that. Let me see, 3072. Is this even right? 768 times 3. What is 768 times 3? Let's go over here. Let's run Python. Let's do 768. 1 second. 68 times 3. 2304. No, that is wrong. Yeah. Okay, so what's 4? Where's this coming from? Let's see. 1024 times 4. Let's do times 4. 3772. What? I just realized something. Let me go ahead and cancel this rendering. Do you want to close? Yes, I do. Let me see. Live streaming physics? What kind of physics? I don't know. Like, we do a lot of physics here, you know? And so that's kind of the thing I wanted to try. Now, lately I've been doing more computer science and physics, but originally this channel was designed, or was based off of doing computational physics. Like, that was the point of this channel. And, yeah, we definitely tried. I watched your last session with the hypercubes and really liked it. Started thinking about how one could do this in Mathematica, and it turned out to be really easy. I managed to make these animations with just 20 lines of code. I also made interactive objects and sliders that you rotate them about. Yep, I realized it's super easy in Mathematica. I've definitely seen it done before. So, yeah. The thing is, though, you kind of ignore some... let me see. You ignore... 1 second. You ignore the projections in the Mathematica code, right? You actually ignore a lot of the computer science with the Mathematica code, which is okay. But it takes a little bit of time to think about it. The other thing is, yeah, you have the planes and everything visualized, which we did not do, but that's okay. Yeah. But actually, this is really cool. Like, it's actually incredibly cool to see this kind of stuff done. Anyway, it was definitely something that I didn't know about before doing these visualizations. So I'm hoping, or I'm glad that it at least helped people understand things. We have the letters for the most exact... Really? Because for what I'm aware of, most people they have a project function. So if we do Tesseract... 1 second. Rotations, Mathematica. Most people just do something like this. So how to create 4-dimensional animation... Here. Most people just do this. They do projection here. Something like this. I don't know. Maybe I just don't understand Mathematica notation. But it's not the easiest thing to... I don't know. I can't read this. Maybe it's just because I can't read Mathematica. But that's okay. Anyway, point is, it looks really cool. Fantastic job. It, probably even looks better than mine do in the end. But that's okay. We're done with the 4D visualizations. It took a week. I never really claimed that we're the fastest here, but that's okay. But yeah, it looks really cool. For the record, this is kind of the stuff that this is kind of the reason why I really like doing this channel, because it gets people kind of motivated to learn things on their own. Now, the thing is, though, this is taking a lot longer to render than I had hoped. So let's see, what do I want to do? I could cancel this render and then render it at a smaller image size. This is okay. Let me see. So what is my size? Oh yeah, it's super cool. Don't get me wrong. Like, this is incredibly cool. I find all this kind of stuff really cool though. So let me see. So we have this done, and what do I want to do from here? I want to go over here. It's gonna take another like 5 minutes for this render to happen, and I don't want to waste another 5 minutes on stream. But let me see. We only have 3 grammatical tenses: present tense, past tense, present, past, and future. Fair enough. Okay, should we just let this guy finish? I think we should just let this guy finish. It's going to take some time. So if you have any questions, comments, concerns, or how about this, guys? If you guys have ideas of what to do for the next simulation, because here's the thing. I wanted to do a genetic algorithm thing next. But I couldn't really find any good applications of genetic algorithms in physics, you know? And I really wanted to kind of keep the stream based off of something that has to do with physics. Now, lately I've been kind of branching off and we've been doing like epidemic algorithms and things like this, but I like physics, you know? And I was trying to find a good application. And the thing is, with genetic algorithms, I know you can solve most applications, like most optimization applications with genetic algorithms, but I am not sure exactly the best algorithm to try, you know? So, genetic n-body simulations, is this a thing? Let me go over here and let's check. So, genetic n-body simulations. Evolving n-body simulations to determine, let's see, what do we have here? We have, okay, well that's not rendering correctly. Let's check the images. Let's go to the abstract. Parameter to n-body simulations, match the test data, involve parameters. Let me see. This isn't a simulation, but how do you feel about doing a paper reading journal club? So something like that. I've been thinking about this a lot, actually, the journal club thing, and I've mentioned it on this channel, and there's been a little bit of support. But I've definitely been thinking, let me see. Open link. What do we have for the straw poll? What to do next? I guess, this is a tough decision, man. I want to do the first and last one, but not the middle one. So we'll just vote for those two. Good. Apparently it is a thing, but I don't know. Genetic n-body simulations. Let me see. N-body simulation here. No, maybe not. Evolving n-body simulation to determine the... No, maybe it's not. Okay, so let's see. What else could we do? So, of course, I Googled, like, genetic algorithms in physics or something like this. Primitive QBAT. Here it is. And we see different stuff around, like application of genetic algorithms to a variety of physics problems. And some of these physics problems seemed interesting, but it's a thesis, you know? And I'm kind of like, it's a master's thesis from this guy. And I don't know, I didn't really understand, I guess, the point? You know what I mean? If it's not, you can make it a thing? Yeah, but I guess I just don't understand genetic algorithms enough to really do that, you know? I've been trying to think about it lately, and I've really, really been wanting to, I don't know, to do the genetic algorithm things. Eigenspace. Let me say one thing. With neural nets are quite useful. We did something with them a little while back. Let's see, so what can we do with neural nets? So we could do some sort of machine learning thing, which I also definitely want to do. Make particles self-adjust to reproduce a double slit experiment. Let me see. Could we do this? I don't know. I feel like we could treat it as a purely classical system. But... oh, we can do this, actually. So if we do an evolution of the wave function, and we measure the fidelity at the end as the... Okay, so this is what we could do. And this is going to seem kind of weird for people who don't know quantum mechanics, but let's go ahead and just describe it and see what you guys are thinking. So let's use Zernal. Okay, so in quantum mechanics, every particle has a wave function, right? So let's do, yeah, so the Schrodinger equation. What is this? Let's not write out the Schrodinger equation. And let's just say every particle is a wave, okay? What we can do is we can actually very quickly, let's say we evolve this wave forward in time and we get something like this, okay? Now let's say for the double slit experiment, we want something like this, okay? These guys are pretty close together. So they have a fidelity, which I'm going to measure as f, as roughly equal to 1, okay? But if this guy ends up evolving something that looks maybe something like this, where you're missing the middle peak, then the fidelity is somewhere around 0.6 or something like this, right? And so what you can do is you can measure the fidelity at the end for that question, how closely you're hitting the objective. And then basically what we can do is we can continually optimize the wave function, right? This is something that people use optimal control for all the time. Yeah, let's see if we can find a good quantum thing. Yeah, why not? We haven't done something quantum-y in a while. Let's do a quantum simulation. So all we have to do is evolve a wave function, find out how to optimize it, and then literally just put the genetic algorithm in there for the optimization. I think that's good. Either 2 or 3, but not both is optimal. Let me see. Add random mutation, add breeding. Yeah, so this is something I have to think about. because I'm not very good with genetic algorithms as of yet, and it seems like everyone else knows how to use them. So, or at least Kark and Gustorn do. So yeah, I guess this is probably a good thing to try. So what I need to do is find a good system to work with, and a good algorithm that we're going to try to work with. And we'll see if we can do some sort of quantum genetic algorithm nonsense next time. We'll see what happens. I'm quite excited with that. Oh, one thing, Eigenspace. As far as the Journal Club thing is concerned, if there's enough support for it, I definitely want to try it. Where basically we just take an article from the archive, we describe which article we're going to go over, and then we all just going to read it together, and we try to figure out what it means and stuff like that. I'm definitely up for this. This is something that I've been wanting to do basically since, I don't know, a few months ago. I've thought of it, and since I thought of it, I've really wanted to do it. But I'm afraid that this channel in particular doesn't really, how do I put this? Because we're doing a lot of programming and a lot of physics, it ends up being that there isn't a physics community on Twitch, and because there is not a physics community on Twitch, there is... No, not yet, Frody. We're almost done visualizing this Tesseract here, and in fact, Eigenspace has a Tesseract up that he just put up. So what's the last thing I want to do? There's one more thing here. Oh yeah, so if we could just have a dedicated physics community, we'd be good to go. Yeah, I'm doing some rendering right now. It's got another minute or two, and then we're done with the rendering. Let me see. Is anyone else here interested in a journal club? So, TS Josh, what is a journal club? Journal club is the following. So we go to the archive. Archive. It doesn't matter where, but just the archive is where we'd go here because this is where all the free papers are. We go to, let's say, computational physics. I'll just go to... where is it? Let me just Control F, computational. Here we are, computational physics. We click on this guy. We find a paper that seems interesting. Sparse blind deconvolution of seismic data via projection gradient. Okay, that one maybe not. But snowflake growth in 3 dimensions using phase field modeling. Now that one sounds interesting. Okay, so we go there. Hey Lolly, it's been a while. So snowflake growth in 3 dimensions using phase field modeling. This is actually really cool. I really like this one. Okay, so now we do PDF. Let's see what it looks like. Okay. So we're going to go down. We're going to take a look at this one. Give it a second to load. And let me see how this rendering is going. Okay, almost done. We have it a few minutes. That's a projection of 4D object, right? It will... Okay, no, that one's the project. That's the 3D object. We will show you the 4D Tesseract in just a second. Sorry about that, Frody. My bad. So let me go here real quick. We have the PDF. It is loading. Give it a second. But basically what we would do is we would disperse this PDF to everyone. And then after dispersing the PDF to everyone, we will then, everyone will read it and we'll all talk about it. And it doesn't have to be too long, maybe an hour or something like that. Whoa, look at that, guys. Holy crap. Also serve as representation of snowflake growth. Using the software Blender, they're using Blender for visual rendering. What on earth? This is so cool. Okay, wait. Would you guys mind if we do this one on stream? I would definitely want to do this one. Snowflake growth in 3 dimensions using phase field modeling. This guy is super cool. I mean, just look at this. I like this. I really like this. Yeah, if we could replicate this somehow, that would be ideal. But it's, you know, if it's on the archive, it's probably like super difficult to do, right? But this seems really cool. But I'm not academic enough to be able to understand anything. Well, that's kind of the point, right? So here, the journal club wouldn't be so... The point of journal club is to... how do I put this? It's to better explain a topic, you know? Because chances are when you read a paper for the first time, it is incredibly difficult to... understand, right? So the point of Journal Club is to make it easy to understand, and the point of you guys being there for Journal Club is to make it even easier to understand. You guys are supposed to ask questions, and then I'm supposed to answer those questions, and that's kind of the idea. So we'll see what happens. This guy still has a few more minutes to render. I apologize, guys, for literally wasting 15 minutes just talking about this while it's rendering, but that's okay. Then you know we can't visualize it. What do you mean we can't visualize it? Let me see. Oh, yeah, so 4 dimensions, we can't actually visualize it. And Frody, just once this is done, yes, you're totally right. Once it's done, I will show you the visualization that we have. Man, I like this paper though. I'm hoping this will turn out okay. Snowflake growth provides us a fascinating example of spontaneous pattern formation in nature. Yeah. Emergent algorithms. Let's do it. Okay, attempts to understand the phenomenon has led to important insights in non-equilibrium dynamics observed in various active scientific fields. I'm sorry, I should probably quit. But yeah, so once this guy is done rendering, it's almost there. We're like 90% done. Then we'll have the video. We'll take a look at the video, and then we'll kind of run through all the videos we have so far. Then after that, what do I want to do? I want to then do one final video to render. This one will take not nearly as much time as the other videos to render will. And then we'll be done. That's literally all we need. Here's something I would be interested in. Let me see. What do we have here? Zesty vote open link? What do we have? Voting simulations. Oh gosh. After this last election, this is real useful. I like this one. This is quite cool. Something related to Twitch things would be something related to Twitch things would be to journal club about physical simulations in video games. Maybe not collisions, but things like rendering physically, corrections, atmospheres, etc. After US election fiasco, yeah, lol, this one seems really cool. Shoot, man, there's so many things that I can just put up. The US was broken before the clown election anyway. That is true. The election system has been broken for a while. Let me see. So the thing about the video game one, right? So I've been thinking about this a lot. For getting video games out or doing video game physics, there's a lot of stuff that goes in there. Happy Little Rat, who sometimes watches this channel, actually watches this channel quite frequently, will tell you that there is a lot of stuff that goes into all the video game physics. And I don't really understand, the best way to simulate the video game physics. You know what I'm saying? Like, because usually the problems with the video game physics has to do with like bugs in the code or something like this. Okay, so this guy looks like it's done. Let's go ahead and go here and let me do an ls and let's run the last MPV slice and dice. Okay, so here we have this guy. Good. That's all I wanted to see. Doing what I wanted to do. Oh, the very last frame. I guess I can cut off that very last frame, right? No one's going to notice if I just cut off the last frame. Yeah, I can cut off the last frame. It's okay. No reason to regenerate this one. Okay, so let's go ahead and close this one. Closing Blender. And let's go over here and let's do the very last visualization. Oh, and also guys, let me pop over here real quick. There we are. Let me do an ls and let me just show you guys a few visualizations that we've done so far. We have the double rotation visualization, MPV, of double rotation, I think .mp4. So here's our double rotation visualization. But let me also increase the speed. So let me increase the speed. That was sbed. Let's do 10. And let's do loop 0. Okay, so here's the double rotation visualization. And now I realize we could have added planes and stuff between everything, but this is okay for now. I like this visualization. It's quite clean. Now we have, obviously, the rotation along X and Y and all that kind of stuff. So we can do single rotation, X. Let's do ZW. Here is a rotation along ZW. And we also have a rotation along X and Y. Let's go here, rotation along X and Y. Now, there's one last visualization I did last time that I didn't show you guys, but looks super cool. And that is the following. And let me see if this flies for you guys. Let me just try something. So if we do projection .mp4 here. Okay. So here we have a tesseract that is rotating both the ZW and XY planes at the same time. And also the projection matrix is changing with time. Okay? So this means that the shadow we're casting, basically the light source along the W dimension in which we are projecting the particles with, is moving closer in to make it really small and then farther away to make it very big. Oh, other way around. Further away to make it very big, further away to make it very small, and then closer to make it big. So light source is going out, and then in, and then out, and then in. And that's what we're doing here. Okay, so let me go ahead and close that. And let me see, I missed a whole bunch of stuff. We'll help everyone. Sidewise tree tabs, wait, what? Open link? Oh, I'm okay with the tabs up here. Hey Frank, let me see, what do we have here? Equivalent to Firefox, let me see, works, visualization, woot, and let me see, curl head, 200 OK, pre-computer to itself. This Tesseract is so mind-boggling. Yeah, it's pretty cool. So now let me just do one last visualization, which I think you guys are gonna like. So let me go down here and let me see, what visualizations do we have here? Let's go here. So let's do project cube, and that's the one I want. Let's go here, move this, change this to 100, and let's just do no rendering of the movie. 1 second. And now let me very quickly just check what we have over here. ls, do we have an out.mp4? ls out.mp4. We do not. Good. Sorry about that. Let's go here, write this, go over here, and now we're going to run... Oh, actually here, let me do an ls out dot... It doesn't look like I have anything here. I didn't put my space... Oh, it didn't put the space in the IRC client either. Weird. Sorry about that. So we're going to not render the movie. My bad. And let's run the last Blender. Okay, so this, guys, is kind of neat. In fact, let me just go ahead. I am going to render it to a movie. Let's go here. Let's render it to a movie right now. -B. And this is the very last visualization we need to do. Outside of that, we can take... the MP4s are... I don't know. Lollygol, this is Python. I can check the size of the MP4s right now, actually. Okay, so let me do an... what is it? DU? Oh, DH? DF. No, it's DU. DU, sorry about the sneeze, guys. Single rotation, XY. Okay, and let me do an H. It is, there are 24 megabytes for that one. However, I bet you that Slice and Dice one was a little bit big. So let's do Slice and Dice. Yeah, no, that one's actually not so bad either. It's only 1020k. It's not bad at all. Let me see. Swedish? Oh. I started learning it with MIT X course in the EDX, actually, as a pronunciation, as an introduction to CS with Python. Yeah, I think Python's one of the regular starting languages now. So we're waiting this to get to 100, and they'll be good to go. Also, every time I sneeze, I do like a sneeze cough. I don't know why. It's always like a snuff or something like that. It's always like a half... it's like I'm sneezing. I'm obviously sneezing, but I do it a lot. So it's like 10 sneezes in a row, and it's weird. Okay, so once this visualization is done, I hope this whole thing makes a little bit more sense. I hope. Maybe it doesn't. Maybe I need to also visualize something else, and I'll ask the question once the visualization is done. So let me see, what do we have here? Yeah, so the MP4s aren't that big. They're only a couple of megabytes in size. Okay, so let's grab this guy once it's done, and it is done, so let's do MPV, out.mp4, and let's full screen it. Okay, so here is a visualization. Oh, let me do a loop 0. Okay, so here's a visualization of a light source moving closer and closer to the cube, okay? And obviously, the closer we get to the cube, the bigger the shadow is. Now, I can do a number of things to make this visualization maybe a little bit cleaner. I can angle the camera down a little bit, and I can do some things there. But I think this is okay for a visualization, right? I mean, you guys understand that the light source is coming closer to the cube. So my question is this. Because this is basically the projection that we're doing, where we have some sort of additional term here. So we have like, in our projection matrix, we have this variable that we divide basically the identity matrix by, and this variable is 1 over 1 minus w, okay? Now, that 1 minus w factor is, we can change the 1, and changing 1 basically changes where this light source is along the axis. So if we change 1 to like 5, it's all the way out here. If we change 1 to like 0.5, it's all the way down here. So we can kind of change that factor. Just to be clear, so you guys understand what I'm doing, let me go to the very top here, and let me show you. So basically, I'm reading in a value here, and I have this temp w guy that we are creating here. So val minus this, okay? So also Blender works on Windows and Mac as well. Let me see. May I ask if you can upload the MP4 so everyone can check them out without rendering them with Python? to help the non-Linux guys, me included. 1 second, what do we have here? Oh, I mean, I'll have a video out, like, literally tomorrow on this kind of stuff. And I don't really know where I'd upload the videos to. I guess I could upload them to Twitch, maybe? Yeah, I guess I could do that. Can we do this till we figure out how 4D objects look like? I can't break these cuffs. What do you mean you can't break these cuffs? Oh, okay. So here's what we're doing. Let me do this. Let's do... yeah, so exactly like TS Joss is saying, the idea here is if you take a... Let's just draw this out. Let's do page, new page before. Here's what we're doing. If we take a cube... 1 second. We can split this cube up into a whole bunch of two-dimensional planes, okay? And if we add up together all these two-dimensional planes, so sum of all the planes, we get basically a 3D object. Okay? Unfortunately, we are 3D objects. So this is us. This is people. Okay? Now, this means that we cannot... Oh, I could put it up. Yeah, we'll see. Which means we cannot really understand four-dimensional space. But what we can do is we can sum a whole bunch of three-dimensional objects, so some 3D objects. And this, in a way, represents four-dimensional space. Now, I have to point out that this is not a visualization of 4D. It's a projection of 4D into 3D. That's what we're doing. I live in Flatland. I'm a 2D person and find this offensive. I'm sorry about that. Yeah, this is exactly what we're doing, right? So we're doing a projection. And so we're projecting two different cubes in particular. A cube at these particular points, page, new page before. So X, Y, Z, and W. We're projecting these at 1, 1, 1. Oh, I'm sorry. 0.5. Yeah, 1, 1, 1, 0.5. And then 1, 1, 1, negative 0.5, or something like this. So we're projecting two different cubes. And basically the difference between these guys is, let me see. Did you read the humorous Trump-like comment above? Making Americans abroad? I missed it, but thanks for pointing it out. Okay, so then the idea is we're basically projecting two different cubes, and one cube ends up embedded into the other cube because of how we're projecting these. And this is your typical form of a tesseract. Okay, so after we have our tesseract, what do we do from there? After we have our tesseract, we then visualize a rotation of the tesseract. And this is where things get kind of interesting. The rotation matrix for two dimensions looks something like this. It's cosine, negative sine, sine, cosine, where all these guys are thetas. Oh, sorry about that. In 4 dimensions, we just tack on an identity matrix and we see a rotation along x and y. Now, these are all zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. However, note that at any point in time, we have two extra dimensions. We have w and z, for example. So what we can do is we can also rotate along these dimensions. And this is something called a double rotation. So let me do cosine, sine, sine, cosine, and these again are of theta. And the double rotation is what we just saw before. So basically one idea with the WZ rotation is that we'll see kind of the cubes envelop themselves. They'll kind of grow and eat the other cube. So that rotation is this guy over here. Let me pop over here. So now we're going to do MPV. 1 second. Single rotation. WZ. I'm sorry, ZW. That I before. And just so I have everything clear, let's do loop 0 and let's do speed 1.5. 10. Okay. Sped is not allowed. Okay. So here is the WZ rotation. Okay. So the WZ rotation is basically a rotation like this. Okay. We cannot really visualize the W plane because that's the 4th dimension, but when we do the visualization, basically it ends up being that we have this weird kind of rotation about like this, you see? And then we have kind of a rotation up like this. So in a sense, it kind of is okay. Okay? And obviously XY rotation looks like about what you would expect. Let me do here. So it looks like just a rotation along X and Y. Right? The cool part is that we can mix the two rotations together, and this will be double rotation to that MP4. And this is pretty cool. So let's do double rotation. And this should be okay. So here's a double rotation, right? So we see it rotating this way and opening up this way. It's quite neat. Now, what we can do is we have different projection methods that we can use. And if we use a kind of crappy projection method, let's just change this to projection. That's projection range, but we should have one more. Projection, bad projection. Here's the same double rotation with a different projection matrix. So this is not doing stereographic projection. This is just projecting with like an identity matrix and ignoring the W dimension. And it's pretty crap. It's definitely not what you would expect. But, you know, it's kind of neat. Hey, the Mad Dave. So, let's see. Then a black hole is infinite dimensional object? I'm actually not sure about that one. Let me see. So I missed a whole bunch of chat. Let me go through and let's see what we have here. Did you read my humorous Trump comment? Send signals from down there, communicate with my 3D mates. Do you know about this game? Oh, Toger, it has been ages. How are you, man? Let me see. Megicura.com. Let me see. Open link. Oh, no, I did not, but this is quite cool. Yeah, I like this a lot. Yeah, thanks for letting me know. Okay, so unfortunately, guys, there isn't so much left for me to do for today, guys. I said that I was going to end a little bit early, and this seems to be true. So let me go ahead and do a write and quit here. Let me do a get status dot. Okay, so we did modify fourth dimension up high, which is obvious because we've been messing with it here. So let's go ahead and do a get add fourth dimension dot pi, and let's do a get commit. So get commit, and let's see. I've been busy and sick and half expected to get banned for posting a link as the first thing. No, you're good. So the reason we used to ban links way back in the day was simply because we used to have a whole bunch of spammers, but now we don't have any spammers, so there isn't really a reason to ban links or anything like that. So now we're going to commit fourth dimension. Oh, just commit M. And what did we do since the last change? We added a couple things. So adding in projection, visualization, and good. So git push origin master. So now, guys, we have access to this now, which is good. So now you guys have it on github.com. And let's just take a minute. So if you want to get to GitHub, just go here, go to info, scroll down to the bottom here, go to github.com right here. And there you have it. You should have access to the latest Python code. All of it's right here. Okay, so now let me just very quickly talk about this journal club thing. So here's the thing. I want to start genetic algorithms tomorrow. I'm not going to lie. I really do. Yeah, okay, so TS Just, my password's kind of long, but it's not that long. It's like, I don't know, 15 characters or something. Okay, anyway, point is, actually, I don't know how many characters. Okay, maybe it's a little bit short. Doesn't matter. I'm not going to talk about my password. I shouldn't talk about my password. Genetic algorithms. I want to start genetic algorithms tomorrow. However, I've got a feeling I'm not going to be able to start genetic algorithms tomorrow. So instead, what I'll do is, if I need to, I will take another day off where I learn more about genetic algorithms. What I want to do is I also want to, what is it? I know, I'm sorry. The actual password is to GitHub is so long. They set up SSH. Yeah, this is exactly what I did. Okay, so what am I going to do? I'm going to say the following. I'm going to say, I want to start tomorrow with genetic algorithms, but I might need one more day off. And this is so that I can learn how to do the genetic algorithms and stuff. The idea that we have with the genetic algorithms at this point involves some sort of quantum simulation, and then we move on to some sort of non-quantum simulation. So we have to kind of figure out what a good simulation would be that would allow us to do our development. You know what I mean? Sorry, we need to find a good system. That's what we need to find. And then we can figure out from there. Okay? Now, in terms of the journal club, I would really like to let me see. What do I want? I would really like to... I'd like to do the journal club sometime soon, but I don't know when yet. So let me go ahead and figure out what the best time for the journal club is. I'm quite keen to read through that paper. So let me read through the paper, and then we'll decide what to do from there. I'm quite excited with the paper. So we'll see what happens there. So what do I want to do then? Okay, so I think that's about it for today, actually, guys. Thanks so much for coming in. Thanks for the incredibly active chat. You guys rock. And one last thing I do want to point out. We now have a Twitch programming Slack channel that I think... Yeah, let me see. So it's over here. So this is what we have. It's a Slack channel here. And let me see. Well, asked earlier. Yeah, so this is kind of the Slack channel. Maybe I should just show my own thing. But it's basically a place where we can talk about that. PSA now, that the stream seems to be ending. A few of us have created a general Twitch programming group on Slack. Yeah, exactly that. So if you want to meet, it's basically a place for us to chat for this kind of stuff. So we'll see what happens. And we can definitely talk about that in a bit. But for now, guys, I think I'm going to go ahead and end the stream. We have everything kind of decided. We need to figure out what to do for genetic algorithms. We have to figure out when to do the journal club. We got a whole bunch of things to talk about. But that's about it for today. Kark, if you want to see the ocean, it is actually too dark to see anything. Here, let me just move this over there. There's nothing out there right now, unfortunately. So, like, yeah, let me just go over here. Yeah, it's too dark. Like, you can't see anything. Maybe if I turn off the lights? Yeah, okay, you can see something if I turn off the lights. But it's quite bad right now. So, sorry about that. There's also a bus over there. Right there, it's a bus. Okay, anyway, guys, that's it for today. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. I'm going to try to stream tomorrow, but I might have to take another day off where I kind of learn the genetic algorithms and stuff. I apologize. It's just I've got so much I have doing. I have so much that I am doing right now that it's kind of difficult to get stuff done. So my apologies for that. But that's okay. So guys, again, thanks so much for coming in. I apologize that today we were basically just rendering videos and stuff like that, but I figured I have to do it anyway, so I might as well do it on stream where we can at least talk and have fun. And that's about it. So thanks guys so much for coming in, and I will see you next time. Bye guys.